Welcome to the introduction of agriculture experimentation. This lecture will look at the process of scientific investigation, as well as the many steps that go into creating the scientific method process. First, before we begin talking about the actual scientific method, it's important to give you a little bit of a historical perspective of how the concept of research and the scientific method evolved. And this really all started with Aristotle. And so Aristotle was really famous for being an influencer. And so this is a very long time ago, about 300 years before Christ. And he was known for just sitting around and thinking about concepts. And when the concepts were put into action and they worked the way that he thought that they would, through his documentation process, everything was great. But there were a whole lot of his thought processes that were actually never tested. And so he would just think on these problems. He never really put his thoughts into action. And so that is what Aristotle didn't do. He never really tested his ideas, which has become a cornerstone of the scientific method. And we had to wait a really, really long time, 2,000 years, before we could actually see the scientific method process start to take form. And that occurred with Galileo. And so Galileo was considered one of the first true scientists. He was very influential and very active in his research the late 1500s and early 1600s. And so he was really influential and considered the first true scientist because he actually went a step further than Aristotle did. So he not only thought about a problem, he made observations, and then he did an experiment. And so one of his most famous experiments was trying to identify if two balls were dropped from the same height at the same time and they were roughly the same shape, would the weight of the balls actually matter which one actually landed on the ground first? And so there was quite a few experiments that he did to carry this process out. And then again in 2009, which was considered the year of Galileo, they actually went through and revisited this experiment on the Tower of Pisa. And so I encourage you to just watch this really short YouTube video about the revisiting of Galileo's experiment. And so that process was then re-investigated when one of the missions to the moon actually took a hammer and a feather and did a hammer and feather drop on the moon as well. And so I'm not gonna be or tell you what the results of that were. I would like you guys to go actually check out these links, and they're linked through Blackboard as well, so it's kind of a fun thing to watch. And so all of these processes evolved over time, and more specifically, they evolved very, very quickly in the last couple of centuries into what we know now as the scientific method. And so this method is really strictly defined as the application of logic and objectivity to the understanding of some sort of phenomenon or event. And so other definitions of the scientific method range from it's a method of research where hypotheses are tested using a well-documented process. It's a repeated process. It is a process of discovery and demonstration. It's an active pursuit of knowledge. And it is the process of explanation of some sort of phenomenon. And so what we have evolved the scientific method to look like is to really investigate and describe patterns that are found in the natural world. And this is how science has taken the scientific method and morphed it for its own purposes. And so this process and this methodology really explains patterns in the natural world. And so this is going to be the major emphasis of not only your individual research project, but also of our class activities. And just keep in mind that the scientific method is really bigger than this class. It's bigger than your major, it's bigger than your education. It's really applicable to a lot of different aspects of life. And the example that I like to give is about how you behave with another person. So for example, if you have never met another person before, you probably have over time developed a way to interact with somebody new. And depending on that person's reciprocation of your actions, you may want to engage further in conversation with the person, or you may just want to run away. And so that process of trial and error is very much along the lines of the scientific method. And so we can see that science is the scientific method is also really applicable to different parts of life as well. And so as we get into looking at the steps of the scientific method and reviewing them, because you guys have seen this probably since 6th or 7th grade on, I want to just lay out the 6 major steps that we are going to focus on in this class. And so the first process is to state the problem. Okay, so we may make an observation and state a problem. The second step is then to take that problem and morph it into a hypothesis. And we're going to talk more in depth about hypotheses here in just a few minutes. The next step would be to then test the hypothesis by conducting an experiment. We would then record and analyze data. And from that data, we then make a conclusion of what the data suggests relative to our hypothesis. So did it support the hypothesis, or did it not support the hypothesis? And finally, we cannot end this process without the 6th final step, to report the findings so that others can repeat and expand the experiment. And so step number 6 here is a really key critical piece of information, because there has been lots of research that has stopped at step 5. Nothing was ever reported. It wasn't put into a peer-reviewed journal. It wasn't communicated through newsletters or extension reports, or even just word of mouth. And so the fruit that research project actually yielded was never passed on to the scientific community. And so we're going to spend a lot of time in this class on step number 6, reporting findings. And so this is where you're going to have the opportunity to actually write a scientific report or a scientific paper in the context of a peer-reviewed assignment. All right, so I saw this meme on Facebook about the path to success in some personal development pages that I follow, and I thought it was also really applicable to research. And so I just crossed out success and put in research as well, because the scientific method and the process of research looks very neat and clean if all you do is pick up a peer-reviewed journal article and read about a project that had taken place and the results that it yielded. But the actual process of research is really quite messy, as shown on the right side of this image here. And so that messy process is one of the things that I enjoy most about research. And if you are a type A personality that likes things laid out step by step by step, I'll be up front. You may be challenged a little bit by this class, and that's good. That's a good thing. My philosophy with this course is that if you are comfortable, then I'm not doing my job. So we're going to set in a semester of just really kind of hard, uncomfortable processes. And hopefully by the end of this, you're going to see this process really come to fruition. And so I just wanted to share with you within the context of research, especially scientific research, what this scientific method kind of looks like. And so we can see that our scientist up at the top of this image has identified and defined a problem, and then he moves on to the next step of forming a hypothesis. After that hypothesis is formed, he can then move into the experimental phase. So that experimental phase can go really one of two major directions. He could make observations without implementing a control or a treatment on a test group, or he could actually perform an experiment by manipulating some sort of variable. And then depending on which way he decides to go in testing his hypotheses, he's going to organize, collect, and analyze data. And during that analysis process, he's going to be looking at the results of that data and asking himself, do the experiments and observations support the hypothesis? And if they do, that's awesome, right? He can draw his conclusions and he can communicate the results. But what happens if the results of his experiment do not support the hypothesis? One option is that gets a little bit depressed, right? And so no. And then he goes into a reflection process. So he can look back through his notes and re-examine the way that he carried out the experimentation and ask himself, was there something faulty? Is there something that he should have done different or have changed? And if that's the case, then he can go back in and tweak the experiment and run a new one. And that is the big loop. He can go back, organize and analyze data, and go through the process again. And so this loop here of asking if a set of data support or not support a hypothesis can be a very long process. And so that's what research really is it's a process. There's not answer ask a question, get an immediate answer. There's a whole long process in between that. And so this area and discipline of research is really messy. The process is messy. And so that's the part that excites me the most about it. And sometimes those processes have to be repeated many times. So some things to keep in mind as we move into talking more specifically about different pieces of the scientific method is I want you guys to keep in mind that you can never, ever, ever prove a hypothesis. People that use verbiage like this, we proved that this hypothesis was supported. That is not the correct way with scientific nomenclature to communicate that result. Okay, so with science and with the scientific method, we can only reject a hypothesis, or we can run a study that results with data that support a hypothesis. So we can reject a hypothesis or we can support a hypothesis. We can never have scientific proof. That term scientific proof is really a common fallacy. All right, so we're going to pick up in the next section talking more in depth about the scientific method.